Hi, my name is Kim Friedman, and my research question for the study is to what extent is teacher pedagogical knowledge in mathematics related to student achievement? The purpose of the study is to discover a relationship, if any, between elementary mathematics teachers' pedagogical content knowledge and student achievement. Elementary teachers are not content specialists. We are certified K through 5 in all subject areas. Teacher education programs provide an overview of all subject areas. The goal of the study is personal. I attended a math endorsement program through Northwest Georgia RESA. The purpose of the program was to support teachers' lack of pedagogical content knowledge, to avoid teachers from using tricks and gimmicks and standard algorithms, and really teach the mathematics behind it and how to teach them developmentally appropriate to students. The goal is also to determine professional learning in mathematics and pedagogy specifically to improve student achievement scores. Lee Shulman was the initial researcher behind defining pedagogical content knowledge. He defined it as a knowledge that goes beyond the knowledge of subject matter per se to the dimension of subject matter knowledge for teaching. So the difference between actually knowing the content and how to teach the content. The limitations of the study were time, sample size, and lagging CRCT achievement data. I only really had a week to collect data on my participants in the study. Only 2 teachers were able to participate. And the data that was used was from 2014 because that is the most current data released by the state at this time. Lee Shulman began research on pedagogical content knowledge in his publications in 1986 and 1987. He was the backbone for future research on PCK. Other researchers that studied this domain reference his definition as the foundation for all of their studies. In the literature review, we learned that it is possible to reliably measure teachers' pedagogical content knowledge, that the effect on teacher knowledge there is an effect of teacher knowledge on student achievement, not necessarily mathematics pedagogy, but mathematics subject matter knowledge. And looking at mathematics pedagogical content knowledge, we know that there is a distinct difference between the two, content knowledge and the knowledge base needed to teach mathematics. But there's not been limited studies on the impact of math pedagogy and student achievement. This study employed a qualitative case study method. 2 elementary teachers, a 4th and 5th grade teacher, participated in the research. The initial research was used in an interview, and the interview was actually a 2-part process. The first part was a phone interview, which probed the teacher's ability to identify common student errors of their students, identify students' understanding of the content, explain the student developmental sequences of mathematics, and their computational strategies that they use to teach their students. The second part of the interview was a problem-solving math assessment in which K through 5 sample tasks were used for teachers to demonstrate their knowledge of how they would teach that standard through that task. Also, CRCT mathematics achievement data from 2013 and 2014 were also collected. A codebook was used to help narrow down the themes found within the interviews. An interpretation of teacher solutions were also completed and put into a table, as you will see in a later slide, and achievement scores and growth scores from the CRCT were also analyzed. The 3 themes that emerged from the interview results were professional learning, including experiences that they've had currently and the needs they feel that they need in the future. Pedagogical shift in mathematics instruction from when they learned math and from when they went to college and learned how to teach mathematics to how it is currently. And teachers' pedagogical content knowledge is necessary to be effective teachers. There are problem-solving tasks. Teacher A used all strategies mentioned in the standard but could not complete the 5th grade task, and Teacher B's model drawing and used number sentences to describe all of her tasks. Here's an example of a task and the task, the standard, the Georgia State Standard, possible solutions, the response of each teacher, and an interpretation. The CRCT achievement results share that there really wasn't a significant difference in their student achievement scores, but there was a significant difference in Teacher A and Teacher B's student growth percentile mean scores. Major findings. In the interview, we learned that teachers need to have a strong pedagogical knowledge, that there has been a shift in rigor, and professional learning is relevant and meaningful in mathematics. In the math assessment, we learned that teachers certified in elementary are not able to complete all K-5 mathematics content, as Teacher A was unable to complete the 5th grade task. And in student achievement, there was an advantage for Teacher B. She was able to complete all of the tasks, and her scores in the student growth percentile scores were higher than Teacher A's. Implications for educational practice, that professional learning that really should be connected in an understanding of mathematical concepts, an understanding of appropriate pedagogical approaches, an understanding of children's mathematics, including the propensity to see and assess the strategies, big ideas, and models in children's mathematics, and to base subsequent instruction upon that knowledge. Teacher preparation programs, that Kleichman was one of the researchers, identified that teacher preparation programs are the key lever of educational reform. Future research, it would be a long-term correlational study, would be useful to determine over time and correlated to all other findings. An experimental design study would also be interesting to note if professional learning in mathematics impacts student achievement. And my references are noted.